All right, what's going on, y'all? This is Sean, and the SAT math skill that I want to go over today is determining whether or not a system of equations has zero, one, or infinitely many solutions. Now, this does show up on the SAT. It has surprised me before, and even as I've tutored for like SAT math and kind of gone over problems and whatnot, this surprised me then. I mean, it surprised me in recent days. Years, I mean. So it's something that you want to remember. It's not one of those things that you tend to have to recycle up for school, but they want you to remember how to determine whether or not a system of equations has zero, one, or infinitely many solutions. All right. Now, so first of all, think about this. So if you have I'm just going to represent this graphically for a second. So say, for example, you have two lines. So keep in mind that whenever you have like an equation can be graphed and it represents a line of some kind. Okay. So let's say that this is I'm just gonna call this E1 and E2. So this line E1 represents equation one, this represents equation two. Now, where those lines intersect is where they are equal to each other. That makes sense, right? Like literally they share the same point at that particular point that they cross. So because they are equal at that point, that means that you can plug in that particular point. It's usually going to be some sort of X, Y, and that point plugged into the equation will solve either of these equations. So that means that in this type of situation, you have one solution for the system of two equations. Now, if you have this kind of situation, you have two lines, they are parallel to each other. They never touch, they never intersect because they're parallel. You have zero solutions to this system of equations. Now, final situation is you have that line there, and like literally right on top of it, you have the other line. That means they share all points in common. They're literally, for intents and purposes, the same equation. This is what you call infinitely many solutions. Okay, so keep that in mind as we go and explain this in with numbers and variables and all that kind of good stuff. Okay. But I think it's good to see it so you can kind of see, like literally see how it all works. So it's not just a bunch of numbers that you just manipulate and hope that they all work out. If you need that, just rewind the video. All right, so here we go. So let's say that you have the following system of equations. Negative 2x plus y equals negative 5. And then you have 10x minus 5y equals 15. Now, keep in mind that both of these represent a line. Now, we know that if the lines are essentially exactly the same, then we're going to have infinitely many solutions. Okay? We know that if you can solve the system of equations and you only get one x and one y, then that means that you have one solution. We know that um if the lines essentially are parallel, then they never touch. And you have You have no solution. Okay. So let's see. So what we want to do here is we want to see what we can determine. Now, there's a couple of ways that you can actually do this here. So what I want to do is I want to traditionally solve this system of equations, and we'll see what we come up with. Okay, so the way that you solve a system of equations is you solve one equation for a variable, then you plug whatever that is into that variable in the other equation, solve that, it gives you a number, and then you'll go back and solve the other one. Okay, so it works better whenever you actually demonstrate it. I'm going to solve this one for y because y is already, it doesn't have a coefficient. We're going to add this to both sides. Y equals 2x minus 5. Okay, so now I'm going to take this for y and plug it in here. So you have 10x minus 5, and then y is equal to 2x minus 5 is equal to 15. Okay, so you have 10x minus 10x plus 25 equals 15. 10x minus 10x is 0, so then you have 25 equals 15. This, my friends, is an impossible situation. 25 is never equal to 15. So you automatically know right there. Matter of fact, so it's not mistaken. Let's put a red X there. This is the situation where you have no solutions, okay? Because like literally this can't be. This can't be, okay? All right. So this is zero solutions. Okay. Now let's consider negative 2x. I'll put a line here. We're going to try something that's negative 2x plus y equals negative 5 and x plus y equals 1. All right, so I'm gonna we solved this one for y in the first one, so I'll do that here as well. So y is equal to 2x minus 5. Let's plug that into y here. So you have x plus 2x minus 5 equals 1. So you have 3x minus 5 equals 1. 3x equals 6, and then x equals 2. Okay, so then you can plug that into here, either one of these really. So I'll just plug it back into here. X plus y equals 1. We know that x is equal to 2, so 2 plus y equals 1 minus 2. So y is equal to 1. So you have exactly 1xy. So this has one solution. Okay, so you see the difference? So literally what you see is that you can solve the system of equations and you'll get exactly one x and y. In the zero solutions situation, you go to solving it and then you get an impossible situation to kind of result. Okay. Now, what about this here? And you already kind of know what I'm going after, but let's just go through the formality of it all. So same first equation. And how about this one here? 4x minus 2y equals 10. All right, now look at this. So if you look at this here, negative 2x plus y equals 5, and then 4x minus 2y equals 10. Now, if you look at this, you wouldn't even necessarily have to solve it to see that there are going to be infinitely many solutions here. Because check it out. This one, if you look carefully, it looks just like this one, except like it looks like it's multiplied by a -2. Look at it carefully. To prove that, I'm going to just for exercise, divide this by -2. 4 divided by -2 is going to be -2x Negative 2y divided by negative 2 is going to be a plus y, and then 10 divided by negative 2 is going to be a minus 5. So you see, these are the same. These are exactly the same. They're the same. So whenever you see that kind of situation where one is essentially like the other one multiplied by some number or something like that, that is where you have an infinitely many solutions kind of situation. Okay. All right. So hopefully that helps. We will go in more depth in the class that I do every Sunday. So keep in mind, if you want to sign up for that, here's the link to that. Otherwise, make sure you like and share this video. Make sure you subscribe, and see you guys around.